Hi there, this is going to be a video on using the local operations of the PolyData tab to get a model that you want for meshing and running a simulation. The first thing you need to know is I've created this model here from some vasculars, path planning, and segmentations, and actually lofting to create a model. It's also possible to import different models such as VTPs, VTK, polydatas, um, STLs, PLYs from other softwares here by just file load surfaces, or in previous versions it's over here to load a different model. But what you want to know about this is that this solid model representation is really just a series of triangles on your surface. So these are all points on your surface, and all these points are connected by edges which make triangles. And so that will help you to kind of understand some of the different operations that we're doing to create a better model. And so I've just created this by creating the two different vessels and then lofting them together to form this junction here. And sometimes you'll have junction that's maybe not quite as smooth as this, a little bit rougher, or just sharp turns because of that junction. So there's some different things we can do to deal with that. I'm going to show you how to do that with this local operations tab. I have this blend model tab here that will be in future versions to kind of help facilitate this, but for now this may be what you have to go with. So what we want to do is there's these different regions for local region selection under this local operations tab. And what we want to do is either use face selection, blend, and what this just means is it will select the region between faces that you highlight and fit a sphere around these two, the intersection between these faces of a certain radius, and then only run operations within that region. There's a sphere region, so you can actually, let's show this here, show a sphere interactor, move this around, and add that region to where you want to run operations, and also cell selection. So you can, to do this, you need to show your model as a full model before you do cell selection, and then you can actually, as this says here, press C on your surface and Shift C if you want to do multiple to kind of paint cells that you want, and then click Add Cells. And so actually what this kind of is here is these are just different ways to select cells on your surface or triangles on your surface that you then run these operations on. And so what I'm going to use to start off with is blend, because I just want this region here where these two different faces are intersecting for my blend. And the way I do that is I highlight, and then I'm holding Shift and clicking for both of my walls. I know this is wall aorta, this is wall right iliac, and I click Add Blend Between Faces. What that does here is this adds this macro here with some numbers. It's going to do a blend. When I run these operations, it's going to do a blend between faces 1 and 2. My sphere radius is 1. This is model face ID. That's not really something that's worked with it at this level. That's more within the code, but that's the ID value of these faces. Active cells, that's just saying the cells I've selected within this region. And 1, you don't need to worry about these last 3 or 4, but if you want to quickly change like the radius, you can change this number here, and then don't worry too much about the values for the faces. That's just these IDs here. And so let's say I want to do a decimation, which is a decrease in the number of triangles. I click then locally decimate, and that will run only on the cells I've added here. And as you can see, that has decimated 25% of the cells I've selected, which in this case is way too many. So what we do then is we click undo, and we go right back to our original surface. And we know this number has to be smaller. I'm going to do 0.01. And so I click locally decimate again. And as you can see, it's kind of decreased the number of triangles here, which is nice. And then I'm going to do a Laplacian smoothing. So I'll click that. You can kind of see it's smoothed out that region a little bit. And a constraint smoothing. Now, constraint smoothing is a special smoothing function within some vascular that is set up to help retain the original surface of your model, but also help you to not lose the volume. If you create a model and do too many Laplacian smoothings, what happens is you end up shrinking the size of your vessels, and that gives you really unrealistic, number one, a really unrealistic model, but then when you go to run a simulation on this, you're going to get unrealistic results because your geometry is wrong. And you also have thinning near the ends of your vessels, which then increases the velocity there and decreases the pressure and just throws results off. So this constraint smoothing is pretty nice because it helps retain the original volume of your surface, but also does some smoothing. So I'm going to do another decimation, smooth. And as you can see there, this looks pretty nice. Looking pretty good. We can run more operations if we want. We can also do a subdivision, quickly subdivide. You can see we've added more triangles here. If we want to continue to do operations, or we just think that gives us nicer representation there, we can do that. So this is just, I've done blend for that specific region. If we don't want to do this anymore, we get rid of it. Face selection is nice if you want to just run operations on certain faces. So say I want to do just wall aorta, add face, and I can locally subdivide. And then if we look here, it's only subdivided this face here. I don't really want that, so I'm going to undo. Get back to my original one. But then you can do sphere region selection, which is pretty intuitive. Show the sphere interactor, select a region. It does only those cells, and then cell selection as well. But if I don't want to do that within that cell selected region anymore, delete, and reselect a region, one of these methods, and then you can run these different operations. So hopefully you can get yourself a nicer PolyData model in this way for meshing and also for running a simulation. So have a great day.